We're working in 5.2 this time, and we'll start on number 12 in my stat lab. And we have a group of men, and the heights are recorded, and we found that they're normally distributed with a mean of 67.7 and a standard deviation of 3 inches. And they randomly select a study participant. And they want to know what's the probability that the participant has a height that is less than 68 inches. So again, even though we could say even 0, or we could kind of debate, we just go ahead after we get set up and go from negative infinity up to 68 inches. So second vars, normal CDF, negative E99, comma, 68 inches, comma, then put in the mean, enter the mean, 67.7 with a standard deviation of 3, and we end up with, I predict, close to a half because, a little bit over, but close to a half because the mean is 67.7, and half of the men would be less than 67.7, and we get 53.98. Next one, find the probability that the study participant has a height between 68 and 71 inches. So second vars, normal CDF, 68, comma, 71, comma, 67.7, comma, 3. I think that I don't even have an estimate on this one, and that's typically the case. So I'm going to go ahead and press enter, and about a third, or 0.3245. One more for number 12, two more for number 12. C, find the probability that study participant has a height that is more than 71 inches. So second vars, you're looking for a probability, so you can use second vars. And the lower limit 71, comma, we'll go ahead and go up to infinity, E99, comma, the mean is still 67.7, comma, with a standard deviation of 3. I hope these are becoming repetitive. And we get 0.1357. Be careful and watch what your author says to round your answer to, or if you need to change it to a percent. Number 13. I'm going to clear out my calculator. Oh, I skipped that one. They want to know, they want you to identify any unusual events. So, unusual events are defined in two ways. The first way is z is greater than 2 or z is less than negative 2, but we don't have z-scores. The second way is often that the probability is less than 5% or 0.05. We didn't have any answers, as I recall, that were less than 5%. So I would choose an answer that said none of the above. So on to number 13. Mean incubation time for a type of fertilized egg is kept at 100.5 degrees Fahrenheit for 19 days. Oh, the mean is 19 days. The temperature is just fact. Suppose the incubation times are approximately normally distributed, which makes sense. It's grown in nature, so it's going to be normal. Standard deviation 1 day. What's the probability that a randomly selected fertilized egg hatches in less than 18 days? So, less than. Again, we could use 0. We're just going to go ahead and go with negative infinity. negative, second, comma, 99, comma, that's our negative infinity, and we got 18 days for the upper limit, comma, the mean is 19, comma, and the standard deviation is 1 day. Let's see, less than 18, I would say about 34. I was way wrong. 0.1587. Gets you in trouble every time. Go ahead and do the TI or use your tables. I recommend you don't use the tables. And don't estimate without looking at a picture. Second VARS, normal CDF. Probability between 17 and 19 days. Mean is 19. Standard deviation is 1. Let's see if I can predict better this time. This time I predict 0.475. Not bad. How's that for redeeming myself? And it's because we're going from 2 standard deviations below the mean up to the mean, and that's about 0.475. Using the empirical rule, the calculator gives you a little more specific answer. Okay, then last one on this problem is, what's the probability that a randomly selected fertilized egg takes over 20 days to hatch? So second VARS, normal CDF, goes from how many days? 20 days, comma, second E99, comma, 19, comma, 1. And this one you could also estimate using the empirical rule. I'm going to let you try that. But we get 0.1587. Okay, one more, maybe. This time, it says use the normal distribution of SAT verbal scores for which N, it's normally distributed with a mean of 515 and a standard deviation of 123. What percent of the SAT verbal scores are less than 675? I'd say most of them, but we'll go ahead and try it. Second, VARS, normal CDF. We're going from negative infinity up to 675, comma, 515 is the mean, comma, 123 is the standard deviation. 90%, or 0.9033. Okay, if 1,000 SAT verbal scores are randomly selected, about how many would you expect to be greater than 525? Less than half of 1,000, so less than 500. And I say that because half of them, 500 would be expected to have a SAT score greater than 515. So, first thing we have to do is go back and do normal CDF again. This is getting repetitive. And we're going from 525 up to infinity in theory. Same mean, 515, comma, 123, close the parentheses, and we get 0.467. 0.76, and we're going to multiply it by 1,000 because we want a number, we don't want a decimal. So about 468. And that's all for those three, 12 through 14. Have a good day. Bye.